Good evening, everyone. Welcome to the day 9 of Agri SAARTHI KRANTI 2026, the 30-day National Agricultural Training Program. On behalf of the Agri SAARTHI team, I, Pooja Kumari, warmly welcome all the participants and today's resource person to this session. Agri SAARTHI KRANTI 2026 is a purposeful initiative envisioned by Ajay Kasana sir, aimed at strengthening agricultural education by connecting learners with expert research and practical perspectives. The continued engagement and learning we see each day reflects the impact of this effort, and we look forward to many more meaningful sessions ahead. I am Pooja Kumari. Along with me, Mushina will be hosting today's session and supporting you throughout the program. I take this moment to warmly acknowledge Ajay Kasana sir, Organizing Director and Chief Secretary of Agri SAARTHI, whose guidance and coordination play a key role in the smooth progression of this training program. The topic for today is caring for soil. Soil health determines productivity, sustainability, and resilience in agriculture. Understanding how to care for soil is essential, not only for crop performance but also for long-term environmental balance. To guide us through this important subject, we have an experienced expert with us today. It's my pleasure to introduce our resource person for today, Dr. Anil Kumar Singh. Dr. Anil sir is a distinguished agricultural scientist and well-recognized authority in soil and water management. He holds an MSc and PhD from Indian Agricultural Research Institute, New Delhi, and was awarded the Honorary Doctor of Science in 2022. He is also a DARD Fellow with international academic exposure from institutions in Germany, USA, and Philippines. He has served in several leadership roles, including Deputy Director General in Natural Resource Management ICAR, Vice Chancellor of RBS KBB Gwalior, and Acting Director of IR in New Delhi. His contribution to research, teaching, and policy have significantly influenced sustainable soil and water resource management in India. His work focuses on soil-water nutrient introductions, irrigation management, and integrated watershed approaches, which are highly relevant to today's topic. With this brief introduction, I now invite Dr. Anil Kumar Singh sir to kindly take over the session. Sir, please.
Thank you very much. I would like to thank Mr. Ajay for giving me this opportunity. I hope the slides are visible. Okay.
Yes, sir. Yes, sir.
So I was assigned the topic which was mentioned as caring for soils. As you all know that soils, we generally refer to Earth as Mother Earth. So that actually signifies the importance of this topic. In my lecture today, I will be having basically brought four, you can say, subsections of my talk. Why we should care for soil would be the first thing. Then what are the issues that are being faced by today by the soil as a natural resource? And then do we have some solutions to take care of the soil? And then what should we be doing in the in the future so that we take care of this particular natural resource? Now, just to refresh people, World Soil Day is being celebrated on December 5 since 2014. This is important because it was the birthday of late His Majesty Bhumid Adulyadej, the King of Thailand. And the purpose of this was that you want to have a platform where the awareness of the importance of soil can be highlighted. So the first was celebrated in the International Year of Soils in 2015. This is the same year when the Paris Agreement was also finalized. And India is a signatory to that. Then they announced that there will be International Decade of Soils from 2015 to 2024. That is finished in 2024. And then, as you all know, Paris Agreement, it is basically how we can tackle the impact of climate change. Their focus was on the greenhouse gases emission reduction. And one of the commitments was in for these Paris Agreement, when we had this United Nations SDGs. I will be talking about SDG Sustainable Development Goals. that certain targets were were identified for 2030. Land degradation neutrality, what we call as LDN, was one of the key subjects that was highlighted in that meeting. And as I said, India is a party to it, and I'll be talking about this also because soil is a very important component of SDGs. Then, Government of India was having a soil health program, but then they decided to give it due importance by having a mission, which is called as the Soil Health Card Mission. It was launched on February 2015 from Suratgarh, which is in Rajasthan. The target was that in 3 years, 14 crores of our farm holdings will be issued a soil health card. And this program has been going on every 3 years. There's the data is being collected and also put on website. Then December 5, 2022, the theme of this World Soil Day was soil where food begins. So this was essentially to highlight that the soil is very important, and it is also important that we maintain healthy ecosystems, because the healthy ecosystems ensure the well-being of humans. And the challenges are being faced by soil management in soil for a very simple reason that it is through soil that most of our food production is there. I'll be showing some data. Then how to increase awareness. What has happened in our country is that our priority in the 60s, when we had this what we call as the ship-to-mouth resistance, that we had had to import 10 million tons of wheat to feed the population. And since then, we focused on the Green Revolution, and one of the aspects of Green Revolution was focus on high-yielding varieties, right? And to get those high-yielding varieties, we had to have inputs like fertilizers, irrigation. Since the focus was on the production or the productivity, because we had to feed, the priority was right that we had to feed the population. So the natural resources were being exploited, and nobody bothered to see what is the situation of these natural resources. And that was the reason why the soil health card program started. Now we have several programs in the country which are dealing with intelligent nutrient management, organic farming, natural farming. All these focus on the improvement of soil organic carbon, which is considered an important parameter of soil health. It is important to realize the importance of soil in that sense that all life begins and ends from the soil. It is the source of food that we eat. The plants from which medicine extracted is also grown there. It filters our water, among others. We always feel that groundwater is more purified wherever the source may be there. But the soil takes care of filtering that. But most of us take soil for granted and assume it will always be around. So that awareness has now come up, and that is why caring for soils is important. And in line with this, in 2024, the theme of World Soil Day was caring for soils, the same topic that I'm talking about today. And what they mentioned was that it is important to measure, monitor, and manage different parameters of soils so that you can manage them effectively without degradation. So I'll be coming back to this as we move across during this lecture. Basically, the topic that is today was identified as a theme for the World Soil Day on December 4, 2024, 5th December 2024. Now, why caring for soils is important? It's not just a growth medium that we are generally used to think about soil. It's a living system. And then if we say living, that means soil is alive. And it supports, and as a part of its duties, it supports food production, water regulation, biodiversity, and also climate stability. The fact is that 95% of the food that is produced directly or indirectly depends on soils. Most of you who are agriculture students know that forming 1 centimeter of topsoil takes hundreds of years. But it can be lost in one heavy rainfall or lost during a single season. So you can imagine that how much time it will take for the soil to regenerate and why it is important that we must take care of soil. If you look at the global scenario, 30%, one-third of soils are degraded because of erosion, salinization. Salinization means excessive salts, compaction because of machinery, acidification, heavy rainfall area, acid rain, and of course now contamination, that is pollution by heavy metals in particular. In India also, we see 30% land is degraded, and it impacts the productivity and also the farmers' livelihoods. So the core message is that caring for soils is essential for food security, ecosystem resilience, and intergeneration equity. What it means is that we should treat soil as something which has to be passed on to our future generations as healthy as possible. So what what do we really mean when we say caring for soils? So there are several functions. One is maintaining and enhancing soil functions, so that we don't we don't focus only on the productivity, that is the yield part. We look at the other aspects. There are soil functions. Now, productivity is, of course, the primary one, but then productivity means it's a nutrient supply of various to the plant. It supports the root is supported through the soil so that the plants can remain rooted and grow properly. It regulates water infiltration, storage, and filtration because water has to be delivered, applied to the soil in most cases. Then from there it goes to the plant, and that is how the plant grows. Then the soil biodiversity. We generally don't talk much about it, but soil biodiversity is very, very important. And over time, we have somehow neglected the microbes and the fauna that are present in soil because of the focus only on productivity. Carbon storage, in the sense of soil organic carbon, it is very, very important, and climate change mitigation is done through increasing the carbon, that means storing carbon dioxide into the soil. And then, of course, cultural and environmental services. We know that soil, as you say, we we call it Mother Earth, and there are several rituals where we try to highlight the importance of soil in our day-to-day life. So the basic purpose is that why we are focusing so much on soil health, that we should now shift from the exploitation part, which has been going on so long. So exploitation basically means that you are not bothered of what happens to the state of soil. We just focus only on the yield. But then we have to shift from exploitation to the soil stewardship. Now, basically, stewardship implies that you are there's you feel that managing soils has to be thought in for future generations. That means you have to manage, the sense of responsibility should be there. So that means careful and responsible management of soil becomes important, so that you feel that this is a, a resource which is under your care, and then you have to see that it is kept in good condition and passed on to the next generation. So you can say that it's something which you owe to the next generation, that you should leave for them a soil which is healthy. So this is basically the stewardship is that the focus has to shift from just considering soil as a medium for producing or whatever it is, without bothering about its health. So just to give you some data, that almost 2 billion hectares of previously productive land has become degraded. International figures show that 70% of natural ecosystems have been transformed, and by 2050, this could go up to 90%. And we also know that by 2030, food production will require an additional 300 million hectares. The focus is that the fashion industry by 2030 would use 35% more land. That means its requirement would be 115 million hectares. When we say fashion industry, it's not only textiles. A lot of cosmetics, are derived from plants. So all those factors are going to put again an additional burden on the land. If we look at India, we have only 2.4% of the global land and a human population of 18% and human and livestock population of around 15%. So obviously, the soil is under a lot of pressure. And if we don't take care of this land degradation, the soil is going to become unfit for cultivation. And that is why we are trying to highlight the importance, why we should care for soils. Now, if you look at, people have been highlighting this important. We all know that soil resource is finite in the sense that whatever our planet is there, it is there. And it's almost non-renewable because I told you that 1 centimeter takes 200 years. And if you look at the Indian conditions as such, for the last, you can say, since 1970, which means almost 7.5 decades, the net cultivated area has remained the same, which means that whatever we have been producing over the years, there has been no additional area brought under irrigation since 1970 under cultivation. And there are no hopes also or possibility that area of 140 million hectares or so, plus minus 1 million hectare, is going to increase. You all know that agriculture is shifting to less productive areas. You know what is happening to urbanization, what is happening to the industrial sector. So all they are actually encroaching on good agriculture land. So in science, they said in 2004 that soil is the final frontier. That means, and then Smith and Kind said that it is the last frontier, which means that if you do something to damage it or don't take care of it, probably it is going to affect our own very existence. And one of the people have stated very clearly that soil erosion is second only to population growth as the biggest environmental problem the world faces. Yet the problem which is going even more critical is being ignored because who gets excited about that? So this is a very serious statement. And as I said, that degradation has been increasing and soil erosion is one of the major factors for that. And as was mentioned earlier, that takes half a millennium to build 2 centimeters of living soil and only seconds to destroy it. One heavy rainfall, high intensity rainfall will wash away several centimeters. And it was the US President Franklin D. Roosevelt said that the nation that destroys its soil destroys itself. So the impact of what happens to the soil as a natural resource which we use for agriculture realizes. Then when we look at the importance, as I said, one of the important things, soil health and productivity, it is very essential for agriculture, as I said, because 90%, 5% of the food is being produced. So unless your soil health is good, the productivity will be affected because it is through soil that you are providing nutrients and also where the microorganisms are there. Microorganisms play a very critical role and they in fact make the whatever nutrients you are there in the soil available to the plant for that day. Biodiversity support. As you all know that probably one spoonful of soil has more microbes than the entire human population. And these play a very critical role in maintaining the ecosystem health. And that is why, whenever we talk about fertilizers, chemical fertilizers, one of the things that is there said the fertilizer accused that because of chemical high concentration fertilizers, it is the biodiversity which is being negatively affected or adversely when you only talk of fertilizers, chemicals. That is why now we focus more on the integrated nutrient management and also encourage organic farming and natural farming, because we are trying to see that the soil becomes alive. Then, as I said, water regulation. Whatever, for example, if you take India, we have about 79 million hectares of irrigated lands. Out of this 79, maybe about 16 to 17 is under drip and sprinkler irrigation. The rest are surface irrigations. So water is applied to the soil. It is the soil retains that water, cleans that water, and then the plant takes care of and provides nutrients. Actually, the plant only takes 1% of the water that is there. The rest of the water is transpired, so what we call is evapotranspiration. But basically, the water, when it moves from the roots to the leaves for transpiration, it brings in all the nutrients and whatever is required by the plant. Carbon sequestration, I said, one of the components of healthy soils is the soil organic carbon, soil organic matter. There where the carbon is locked. And therefore, we focus a lot that if you can to increase the carbon sequestration in soil, you can probably reduce the impact of climate change. Nutrient cycling, I said, whatever fertilizers we add to the soil, and that is taken up by the plants. So obviously, all this thing we do is for the food security. So if there is no soil, proper or healthy soil, our productivity is going to be affected. And then, then comes the important part, that if you really want to take care of the soil, you have to keep on monitoring and measuring the different parameters of soil health and see that we prevent erosion, nutrient depletion, contamination, and through timely interventions. And that is why when I said there were three, monitor, measure, and management, they all three go together. And when we say management, it has to be integrated, because just focusing on soil is not sufficient, because you have to take care of the crops. You have to see how the soil health is maintained or enhanced, because the soil is able to maintain the productivity level, or in fact, increase the productivity, because as I said, we are not going to have more land for our food, for our crops. So you have to produce more from the same piece of land, and that means more stress on that. So how soil, so you have to probably see all those factors and manage. And obviously, if you really want to do anything on the ground, there has to be a proper policy, which is the responsibility of the government, and then the awareness among all the stakeholders. So that is why we say that a policy there, and as I said, soil health mission in 2015 was launched with that purpose. We have all awareness programs through self-help groups and training programs. We have this network of Krishi Vigyan Canes. They try to tell you what is how best to take care of your soils. And then I'll be talking about the Sustainable Development Goals. As I said, that India is a party to this, and one of the goals deals directly with the soil, and soil impacts many other SDGs, and I'll be showing you how all these affect the SDGs. This is the 17 SDGs, which okay, and they were adopted, as I said, in the Paris Agreement 2015. Basically, with the purpose of these SDGs is that you have to end poverty, protect the planet. Protect the planet means that you need a healthy planet also, and then that will help in improving the lives. So these are the 17 goals. The you can say the 15th one, which is the life on land, one can say that this is linked with the soil only, but in fact, many of these are affected by soil. Okay, there is some problem. Is it changing? No.
Yes, sir, it's working, sir.
Uh, uh, okay, now you can see that?
Yes, sir, perfectly visible, sir.
Okay, yeah. So this is, as I said, though it is only this 15 which talks about life and land, but the soil impacts the number one, that is no poverty, which has been an objective of the Million Development Goals and also the Social Development Goals. Then the second goal is zero hunger, which means that zero hunger means uh, you have to increase the crop productivity so that the population which is increasing, that is provided with the food. Then good health and well-being. So this is very important because depending upon the soil health, the the foods, the plants that are produced, they will depend a lot because whatever you give is available in the soil, the plant takes up. And as you all know, we say that about 17 major secondary and micronutrients are essential for plant growth. If there is any deficiency in these, that is affected in the health. And you all know that as when it comes to food production, we are in fact producing and exporting food. But if you look at the nutrition aspects, we find that the women and children in India are quite malnourished and it has a very low rank in the global health index. That is why it becomes important that you need to have a soil which is healthy. Healthy means it has all the positive aspects of that. Then clean water and sanitation, as I was mentioning you, that what the soil also does the part of sieving and filtering the water. So this becomes very important in maintaining the water quality. The other thing which is the number 12 is responsible consumption and production. Now, nowadays a lot of discussion is there on the waste reduction. So, you have to manage all the inputs properly. That is one thing. So don't stop waste losses at that level. And then after the food is produced, it makes its way from the farm to the industry to the consumer and all that. And then what we eat also. So almost it is said that 30% of food is being wasted every year. So if you calculate back from that 30% that is being wasted, how much resources are wasted because of that. And as I mentioned, 13, the climate action, that is goal number, SDG number 13. The soil is the medium where you have to store all whatever carbon is there. There are a lot of scope for that, and that is why the government is also focusing a lot on carbon sequestration. Again, it also affects, we might wonder why goal number 14, but actually there's an equilibrium between the soil at the bottom of a pond and in the water above, which takes care of the aquatic life. And of course, goal number 15, that is soil itself. Biodiversity is again a very important part. As I said, the soil must be alive. Only then there will be biodiversity. Okay. It seems to be a bit slow in turning. Okay. It is visible now?
Yes, sir. It is visible, sir.
So this is I was mentioning about the SDG goals when they were, finalized in 2015. So we have certain national priorities and we have international commitments. What is the role of soil in that? I just wanted to highlight that. If you look at the national priority, of course, food and nutrition security is there. I mentioned we are very kind of comfortable as far as food is concerned, but we are having for quite behind in the nutrition security part, and that is being now addressed by producing foods that are biofortified. Then, of course, you have to increase the income and job opportunities for the farmers and everybody is involved. We have to reduce environmental degradation, and that should go along with the improvement livelihood and sustainability. Sustainability is important because our population, we are already the most populous nation, 1.4 plus, and it is expected that by 2050 we will be around 1.64 or 1.65 billion people. So we have to provide not only livelihood, we have to also provide food and with limited resources. What are the government commitments? One is that you have to reduce the emission intensity by 45%, with 2005 as the base level. As you all know, fossil fuels are being blamed, so 50% energy from renewable sources. And I'll come to that just now, just in a few seconds. Then, of course, raise non-fossil fuel-based energy capacity to 500 gigawatts, solar energy, wind energy, these we talked about. We have to cut carbon emission by 1 billion tons to meet this target by 2030. That means we have to keep on sequestering that much carbon dioxide equivalent in our soils. The land degradation utility target, restoration was 26 million hectares, and this was announced by earlier it was 21. Then when we had this meeting in India, the target was raised from 21 to 26 million hectares. Now, then another commitment is that by 2070, at a net zero emission and carbon neutrality, that means we will stop any increase in carbon dioxide or any of these greenhouse gases. Whatever is being emitted is going to be taken care. By 2025, the target was 2030, and for ethanol blending in petrol, the government preponed that target. So now it is already there by 20% in 2025, and as you know, government has implemented this last year. So there was some UN cry about that. Why ethanol blending affects soil is because you have to grow crops which are going to be used to generate or produce ethanol. So again, a competition with what is being done by that. Then how can Indian agriculture contribute to fulfill these commitments? Can the agriculture become climate resilient, carbon neutral, considering all these targets, considering the fact that we have to produce more food, our population is increasing, we are still a developing nation, and we have to uh, do a lot more by 2047 if you really want to become a developed nation. So all these factors are going to play a very critical role when you want to have this carbon neutrality by 2070. Just passing information about climate change. I think a lot of people must have told you about this. The fact is that Indian agriculture is only giving 0.8% of the global and 14%, right, as far as Indian GHG is concerned. The important thing I want to highlight in this one is that earlier when this shows the contribution of the various sectors to different economic sectors to the GHG contribution, agriculture is now 14%. If you break up this 14%, then, of course, enteric fermentation, that is the livestock, is about 55%. Earlier, when this whole thing of climate change started, methane emission from rice was the one which was blamed as the maximum contributor after the enteric fermentation. But the latest information is that the nitrous oxide emission from agriculture soils has become a larger contributor than the methane emission of rice. So this becomes very important when it comes to soil. So both methane and nitrous oxide emission, soil plays a critical role, and we'll be talking about this. That is why probably it becomes more important that we have to see how we can reduce this, because nitrous oxide has almost 300 times the impact on the climate change. Okay, now just to go back to what we were doing earlier, when we talked about the green revolution. The critical inputs were seeds, that is high-yielding varieties, water, that is development in irrigation structures, irrigation infrastructure, fertilizers, that is the chemical fertilizers, that were because you had high-yielding varieties, they needed more inputs, so you had to provide from, and it was not possible for the soil to provide that much input, so we have focused on fertilizers. Then plant protection was the fourth pillar of green revolution, where we had to control the losses due to weeds or pests. Tillage became important because you were thinking of, as you all know, the earlier theory was that you have to prepare a good soil tilth for crops to grow, and of course you need labor for all these activities. We all know that even today about 50% of the rural population is involved in agriculture. But what happened now is that when we talk of the critical inputs when we talk of climate smart, climate resilient agriculture, or the evergreen revolution. We still have the same factors, seeds, but we want more input efficient, abiotic and biotic stress tolerant and nutrient fortified varieties. Okay. Water, we want, because water is becoming scarce, we, instead of talking of just what use efficiency, we say now water productivity. How you can enhance income per unit quantum of water. Fertilizers, we have to increase the nutrient use efficiency. Why? I will show you some figures. But our fertilizer use efficiency is very, very low. And that not only implies waste of resources, also the negative impact on the environment. Because of environmental factors, herbicides and pesticides use what we want to minimize. We also want to minimize tillage because it requires energy, it requires fossil fuels, and then, of course, the cost to the farmer. You have to maximize the labor because that means you need mechanization. And all this then has to be done. And then we call what is now we say is the evergreen revolution. So basically, the interesting thing is, if you look at these, soil doesn't appear anywhere in this when discussion there. But whether it is sowing, whether it is applying water, whether you apply fertilizers, spray herbicides, do tillage or mechanization, soil is the one which has to receive all whatever activities are there. So it is at the receiving end of all these activities. It doesn't figure anywhere in this narrative. Okay, now what people have estimated is that if you want to feed a population of, let's say, 1.7 billion by 2050, the land productivity must increase by 4 times, the water productivity by 3 times, labor productivity by 6 times. This has to be done using technology which is low emission technology, that means green technology, less impact on the environment. As I already mentioned, that this is the amount of 141, 142 that is in net cultivated since 1970. Hardly any scope for area expansion. And as I said, intensification of agriculture activity is the only option. What this is going to lead is the strain on natural resources, and land is being converted and degraded at unsustainable rates, which is damaging production, ecosystem, biodiversity. What is the solution? That you have to use technologies like biotechnology, modern tools and techniques, how to improve the resource input efficiency. Precision farming is one issue which is being now talked about all over the world, more so in India. So how do we do all these things becomes the next question. Just to show you, why I'm showing this figure is that we have committed, restoring 26 million hectares of land by 2030. This is a report by ISRO. You can see that the latest one, which was published, the degradation has increased. From 94.53, it has increased to 97.85 million hectares, and which means in the percentage, of course, it looks only 1%, but for a country like India, 1% increase in desertification, where we were wanting to reduce it, is making a big impact. If you look at the resources, water erosion is, of course, the main one. Vegetation degradation is the second main factor, and then wind erosion. So these are the three main. Of course, we have waterlogging, salinity. Compared to all these three are the main factors which are contributing to degradation. And if you look at the land use, unirrigated land, again, 38%. That means rain-fed areas, which are still about 45%, 42% or something like that, 44%. They are the ones which are getting degraded. So this is rain-fed area. Irrigated area is not so much because we level the land and all that. And of course, the forest degradation is there, scrubland area which is there. So all these are the ones which are getting degraded. If you look at And if you look at I mentioned the area about the degraded area. We have about 5.65 million hectares of grassland area, which we have lost. Desertification, I already showed, it has increased. It has increased, in fact, 26 out of 29 states. So situation not very happy as far as desertification is concerned. And 80% of these degraded land lie in only 9 states of the country. It's not that government has not been doing anything. There have been measures right from 1974, Command Area Development, Integrated Watershed Management Program, and, dryland projects, conserved catchment area, river valley projects. All these activities programs are there. But the impact has been, as I mentioned, as per the ISRO report, the degradation has increased. These are the state-wise. You'll be surprised that even states like Punjab, degradation here doesn't only mean that soil erosion. It means, for example, if you're adding chemical fertilizers, soil health, that's also degraded soil. So you have all these, and this is the increase since 2003 and 5. That means in the last 20 years or so, this is how degradation has happened in the states. So the situation is not really very encouraging if you look at what is happening at the ground. And then what happens is that there's an annual economic loss of almost 3.17 lakh crores. That means about 47 billion US dollars in 2014-15, which represents about 2.5% of the country's GDP. And it not only it's the loss to the government in terms of rupees, it is also impacting about 3.2 billion people. And more than 10% of the annual global gross product is lost in biodiversity and ecosystem services. So as I was mentioning earlier, by 2050, if they can lead a reduction in crop yields by 10% and up to 50% certain regions, which will force 50 to 1700 million people to migrate. So this is how the environmental degradation happens, and these costs. So we always say that probably prevention is much better than trying to work out a cure or solving the problem once it has happened. Another thing I wanted to just mention, why the management of the catchment area is important. If you look at the per capita storage, this is China and this is India, two countries of a similar population. The per capita storage of China is 5 times than what India has, same population. Now, the figure that I mentioned here is that because of silting in our water reservoirs, it is at the rate of almost 1.95. That means 2 billion cubic meters every year. If you look at this from the rupees point of view, that means if you want to, because of silting, the capacity that has been reduced of these reservoirs, because productive soil has come from the hills, from slope, along with the water and deposited in the reservoir. So that is productive soil, which is at the bottom of your reservoirs. That is one loss. Second thing is that if you want to increase the capacity, which was there earlier before silting occurred, you will have to spend about 20 billion rupees, okay, to create that much additional resource, which you have lost because of silting. Again, loss of soil, loss of storage, and then, of course, the money involved in that. So this is very important, that why we should. In crop residue recycling, I think we have heard quite a bit, particularly those when the winter comes in Delhi, this crop residue burning becomes a big issue. We have the estimates are we have 250 million tons of crop residues, 100 million tons of carbon, so which means that 100 million tons of carbon resource available to soil from field crops. We have almost a lot of wastage, about 80 millions out of the 320 million. This was in the earlier year. Now, of course, more than 350 is the horticulture production. So that is the fresh amount wastage. Dry could be, maybe 60-70%. you can remove from that. Then rainfed crops also burning is increasing. It's not that it is only confined to Punjab and Haryana. I've seen in MP, Bihar, everywhere burning is happening. You can use this straw to make biochar, which can improve fertilizer use efficiency. And uh, uh, you can always produce this locally, biochar. And there are models where even at the KVK, at the farm level or a cluster of farms, you can have biochar being produced and used and applied this way. So when we talk in terms of nutrients, that is each ton of crop residue, we had 250 million tons. We lose about 5.5 kg of nitrogen, 1.2 kg of sulfur, 2.3 kg of phosphorus, 25 kg of potash, and organic carbon about 400 kg. This is important because you want to um, uh, reduce the amount of fertilizer, chemical fertilizers. Also, you want to increase the organic carbon. So, and when this organic carbon is burnt, CO2, N2, and methane, they are the ones which are uh, generated. This is just approximate cost that in wheat the fertilizer cost is about 3,000 per hectare. If you can improve the nitrogen efficiency by 10%, you will save 300 rupees per hectare. And 30 million hectare wheat, you can imagine that how much fertilizer will be saved. If you work out the cost for rice where it's about 8,000, 10% means 800. And we have about 40, now it is more than 45 million hectares of rice paddy. So you can see the amount of government money that can be saved if we utilize these crop residues, recycle them instead of burning them. The other important aspect I wanted to mention is all of you who must have, those of you who have traveled along the highways, have seen a lot of brick kilns there. I mean, and these brick kilns are actually utilizing the most productive soil, and maybe 50 centimeters to 1 meter or even deeper. All those soils are removed. India is the second largest brick producer in the world. And I have given some figures. That means right now, probably it's more than 0.8 million hectares of agricultural land which has been lost through bricks. I think you all must have seen them. And then it's not only that you have lost soil, all this burning of brick burning also emits CO2 or CO2 equivalent along with coal combustion. So it's in the 42 teragrams of CO2 are being released because of the brick kiln industry. And once this brick kiln soil has been removed, the economic yield will be reduced from 60 to 90% when you bring that area under production. So that is why government says that you should not use bricks in the building. They say fly ash bricks, but then the how to utilize them brushes, because these bricks are available locally. Fly ash is being produced other places, so transport and all that. So that's why the figure says that out of 170 million tons, only 107 were utilized. The rest was not, in spite of and this demand of bricks is going to increase. As you know, the government is committed to provide a home to all the people in the country. So where will all this come? And 25th, this almost 4 to 5 times would be there. Now, these are the problems. If you look at the state of soils in India, I mean, many of you must be knowing about these are being talked about a lot. The NPK are the major nutrients. You can see the level of deficiency. This is sulfur is a secondary nutrient. These are all micronutrients. And you may remember that in zinc became very important during COVID as a micronutrient which is essential to for your health. Iron deficiency is there. As I said, anemic 50%, almost 40-50% women are anemic, plus and stunted children also. All these micronutrient deficiencies affect human health and also animal health. And now we have found that even magnesium deficiency is there. Of course, you might be knowing now that manganese is now being recommended as a regular for applying in wheat as a fertilizer for wheat crop, at least in Punjab. So these are things again which are increasing, sorry, and these are the ones which are very important and are used for defining the soil health. If you look at the efficiencies of these nitrogen is about 30 to 50, and I have given the various factors there. Phosphorus 15 to 20, potassium 70 to 80. Now, this is textbook information. We are all aware of this information. But it's not that we have not been doing anything about the efficiency. So many options are there how you can increase the efficiency, whether it's nitrogen, phosphorus, potassium, or micronutrients, only neem-coated urea, and now, of course, nano urea and all these are coming into the picture, will increase the efficiency. But overall, if you see, the efficiency level is very, very poor for all these. And they even say that you can probably, if you, because phosphorus gets fixed, it's probably, if you can apply in wheat and don't apply in rice, probably you'll be able to increase the efficiency without affecting the productivity. So these are simple measures. Then we also have um, now control release for fertilizer. Neem coated urea is just something you can add, which releases the nitrogen slowly. There are other nano, as I said, is one which is being done. There are also polymer coated fertilizers. Of course, right now they are called smart fertilizers, but the cost is high, so it's not there. Only nano versions are now being are available now. So, but there are many options, and one of the reasons why uh, all these things don't happen is because the subsidy part is so high that the uh, fertilizers are being made available at a very low cost. So that is one of the reasons why we are not really gaining much on this part. Now, this is just to show you one slide. There are, so as I said, I have mentioned so many ways in which nutrient use efficiency can be increased. This is one of the land leveling, laser leveling is there, which actually started as a practice so that you can save water, essentially. But if you save water, the mantra is very simple. That if you increase the water use efficiency, you improve the nutrient use efficiency. This slide I'm just showing of laser leveling and TL is the traditional leveling. That if you just do this particular operation, you can see the agronomic efficiency of nitrogen, phosphorus, potash. What impact it has made? It's almost double. So this is one very simple way that if you take care of land leveling and managing your land properly, you will always benefit in terms of nutrient use efficiency. Now, this is one example I would like to highlight here. As I said, we were blamed about methane emission rice fields when the first time it started. India was blamed, India and China, that a lot of methane has been emitted because of rice fields. India has the largest area under rice. There's no doubt about it. Much larger than even China. And this was the figure which was quoted at time, right? 37.5 million tons. We were there and then we said, no, this is the way they have computed is not correct. You have to come up with some realistic figures. And then we did some work at IRI. And you can see now that from this level, the figure now that is now being generally agreed upon is 1/10 of that, right? So from 37.5, it has come down to 3.3 or 3.5. And now consistently we are maintaining this level. So we were blamed for methane production, but then the reality was, this is why we say measure is one very important component when we talk of caring for soils, right? Because you were able to establish that we are not responsible to the extent that India was blamed. And I generally say that it is not the crop. We say rice which is to blame, but it is not rice, in fact. It is the soil and water management that determines the greenhouse gas emissions and not the crop. And this is one shows, so this is for lowland rice. Lowland rice means rice which is uh, filled with flooded with water through the crop season. Okay, let me put it this way. So then we have this, but other crops, we all know that sugarcane also requires a lot of water, but you can see the difference and a more duration crop than rice, and then the other crops is very, very low. So that is one thing which is important that we should remember this. That soil and water management becomes very critical for these. Okay. Now, this is another example I would give. Now, we have all heard about arsenic. It started from Bangladesh, and it is there. And basically, the reason was, I mentioned here, is that methane emission in rice, and then arsenic toxicity, because uh, they wanted to irrigate rice, the paddy crop. They pumped in a lot of water from the aquifers, and that dissolved arsenic from the ferrioxy hydroxides. And then when this impact of arsenic was reflected in the health of animals, nobody bothered, and humans. Humans in first, then animals. Nobody at that time bothered to see why it has happened. So this toxicity occurred, and again I call it soil and water management, because if you had managed water properly, arsenic wouldn't have come into the water and affected the rice crop. Then rice crop, because rice became toxic, then the animals who consume, the human beings consume. So that was, and that is why now the government talks about One Health approach, because soil is the starting point in this soil, plant, animal, human agro-ecosystem chain. So if you take care of soil, you can take care of many of these problems. These are two issues I take. That is soil and water management. We should not blame rice for these problems. The factors are different. Now, this is another one which a very simple side that shows that if you apply nitrogen as a single basal dose, and instead of that, if you apply in different splits, so this is the amount of nitrogen that will be there. So a lot of loss is prevented. What we do is, because of labor requirement, we would probably just do basal or reduce the number of splits from this. But here you see, and this is what is actually reflected in the fertigation. So when we start looking at fertigation, where we can, because we are able to give water more frequently at our whenever we feel like, so we can also give water soluble fertilizers as in when we would like. So that labor part is taken care of. You can see the efficiency with that, how this happens, right? And a very simple experiment, which was much before this paper was there. Rhodes group had done it. You can see the fertilizer treatment conventional improved was just the same fertilizer, but given in increments of 5, 5, 10, 20, 20, 20, and 20% during the growing season, right? Same amount of fertilizer. Now, and then the important thing is it was fix the schedule that so much water is going to be given every day, and then you can see the yield level in this fertigation. Then they also scheduled use a tensiometer. So depending upon the stress observed from the soil, the metric potential, then the irrigation was given. So here you can see 50 centimeters was given, here 26 centimeters. Yield is higher. Water use efficiency is also much higher. So this was the one which indicated that why fertigation is going to be very successful. So the same measure, you can see that you have saved the fertilizers. I'll just show you the figures that are available with the use of these irrigations. So this is how you can improve the efficiency of both water and nutrient. It's not that you need drip irrigation always for that. This is one thing. Very simple. This was done in maize crop. We generally apply basal application on the day of sowing. But they said if you can delay this basal application by 7 or 14 days, this is the nitrogen efficiency, compared to 50% here, it increases to 60%. 10% efficiency can be increased in nitrogen use efficiency by just delaying the basal application, okay? Which means that instead of at sowing, you give it by 2 weeks later. That is the benefit you'll have. Again, something very simple. The other is how you, when you irrigate, okay? So you can see that if you give the fertilizer before irrigation, right? And so you can see not only the grain yield, the 15 nitrogen percent radioisotope nitrogen was used, 15, and the recovery is 52% compared to this one. So you can see the difference, right? That after irrigation and before irrigation, if you do the irrigation after applying fertilizers, both the recovery and the yields are affected. This is the yield level. So these are again studies which have proved. Now I'll give one very interesting example. When the prices of fertilizers increased globally, and this is an example of Bangladesh, the government said we cannot afford to give you increase the or take care of the increased cost. You have to manage whatever price is available. So then they started working on urea deplacement technology, right? So they had briquettes made of urea, and then they developed a machine to uh, um, you apply them in the rice fields. Of course, as you all know, Bangladesh rice is the main crop. Now, what happened was that earlier they were applied 3 times earlier during the crop season, spread dose, and only 40% was utilized in plants. As I mentioned, you see nitrogen efficiency, 60% is lost. So when the urea in the form of urea super granules was applied, it was applied only once, 5 to 7 days after planting, like only once. And instead of the normal dose which they were applying, only 160 kg, 247, 160, that means 35%. So this 35% was the one which compensated for the price. And also the benefit was the rice yield increased by 20%. So this is, and this technology, and they have been, I think, if I remember correctly, have a motorized version of this applicator. This is one technology which can easily be adopted in West Bengal, Odisha, Bihar, where you have rice, but it's not being done. Okay, now this is one example I mentioned. See, I mentioned about drip irrigation, I mentioned about arsenic. Now, this is one example, you can see, an interesting one that normally nobody thinks of rice being grown in drip. It is being grown, now it is being evaluated, and a lot of work has been done, and you can have rice. This one shows that the same soil, only thing is in the flooded condition, and this is using drip. You can see that same soil, here is 5.7 arsenic, here is 5.8. There's hardly any accumulation of arsenic in the plant, any part of the plant. Although the concentration in the soil is the same. So again, this is another benefit that for drip irrigation, you are using less water, less fertilizers. You are able to eliminate the arsenic poisoning. Labor, because when you have drip, you have a system at your disposal. You can irrigate when you want, what you want to do. Once you have the system, the labor cost is also reduced. In addition to all these things, pumping time and all that. So again, a combination of irrigation and how it helps. Now, this is just to give you illustrate what is happening. See, when we see the figures of fertilizer, these are the figures that are generally reported, fertilizer kg per hectare over gross area. Punjab, Haryana, Uttar Pradesh, and all these things. We say 241. But actually, if you take a crop like a state like Punjab or Haryana, where the cropping intensity is 190% or 190 plus, or for example 187, 182% in Haryana, you are in fact and you are working out this fertilizer kg per hectare over gross area. If you look over net cropped area, because the same piece of land is receiving in Rabi and in Kharif, two crops, you can see what level of fertilizer we are applying. In the case of Punjab, it is 400 plus, Haryana is all 375, Uttar Pradesh, even a state like Bihar, 300 plus. So these are the actual fertilizer that you are applying on the same piece of land when you talk of net crop area. And imagine if you take 30 or 40% efficiency, or even say 50%, rest of the 50% of this fertilizer, right? So this is important, that why we need to improve the efficiency of that. And just by saying that we have only applying 250 kg and China or Russia is applying so much, doesn't make sense, because we have to look at these figures, and these are the figures which make the impact on the environment. So this is just to show why we need to improve the efficiency, and this is just to show you the amount of money that is being given as the fertilizer subsidy. Can you imagine 1.75? It is almost 2 point something for 24-25 also. So that's why they started one program called PM program. This is PM Pranam. Pranam is PM program for restoration, awareness, nourishment, and emulation of Mother Earth. That is how you can take care of the soil. And this is the promotion of alternate nutrients for agriculture, which in basically this means that if a state is able to reduce the fertilizer usage, that means it reduces the fertilizer subsidy that is paid to it. 50% goes to the state, 50% goes to the farmers who are adopting technology which is useful for which saves fertilizer, or increases the efficiency of fertilizers. So this again, this is in addition to the organic farming or natural farming practices. Okay, so these are the policy decisions at national level. Soil health card, neem coated urea, nano DAP. You have sulfur coated. Pranam is one. Crop insurance scheme is there. Water availability was, I said, in this particular program, they are putting a lot of focus on PM Krishi Sinchai Yojana, a lot of focus on drip and sprinkler irrigation. In fact, the targets are very, very high. Currently, it's about 17 million hectares. Now they say that, in fact, 72 million hectares plus can be brought under sprinkler and under micro irrigation. And we, as I said, we have about 17 million hectares net irrigated area. Agroforestry mission is very, very clear, because if you want to sequester carbon, agroforestry is one of the best options available for that. Then the government is also focusing on integrated farming systems. Why it is important is that you are trying to reduce uh, the amount of external inputs which a farmer needs to apply. So trying to generate some nutrients through the farming system, so that you apply less fertilizer, buy less fertilizer. So that will also help in reducing the burden on the environment. And people have already worked out that what sort of integrated farming system, how much nutrients you can save in terms of nitrogen, phosphorus, potash, even micronutrients, and that again helps the environment. This is just to show you that so many technologies we have been working on, which have been developed. Zero tillage, laser land leveling, direct seeding of rice is being promoted uh, by many states, Punjab, Haryana, in particular. Raised bed planting is one technology which I feel where you don't have micro irrigation system, that means sprinkler or drip, that land. Every crop can be grown with raised bed planting. You have to just probably do the land configuration part properly. So this is very 10 to 20% efficiency in water use, nutrient use can be having just if you switch over to raised bed planting. A lot of work has been done, which indicates it's possible. And the advantage is that this works In areas where you have more water, because these furrows drain out water, and they also conserve water, so the rainfall conditions also, some water is retained by this, and the crop is able to survive. Leaf color chart, a very simple way of predicting fertilizer. Again, some of these institutions are doing it, but again, large scale, I would say large scale is not being followed. Residue management I already mentioned, sprinkler drip I have already mentioned, that these are things which can improve. Coming to the next slide. Now this was just the previous one was just giving you in qualitative terms. This in the quantitative terms. Laser and leveling, what is the benefit in terms of productivity? 0.5 tons enhancement, profitability by 14,000. That is the gain. Water savings in 15% and greenhouse gas emission mitigation by 0.5%. So individual technologies, how they impact. Then a combination of zero residue, direct seeded rice, permanent beds. This is site-specific nutrient management. That means you give only fertilizer as per the requirement. Uh, Instead of drip irrigation, now people are also trying subsurface drip irrigation, and that even saves more water. And then the crop diversification, you take crops which are more water efficient, nutrient efficient. And if you take this climate smart agriculture package, that means some of these practices, you can have an incremental benefit of productivity in terms of 1 ton per hectare. Probability gain would be 15,000 over what you're getting it. Water savings 20%, and this is 2.9 tons CO2 equivalent. So, and of course, the energy requirement in land preparation. So these are the ways in which you can help the farmer as well as the environment in terms of now, the other important aspect which is being talked about a lot is on field variability. We probably are now started talking of how to precision farming or whatever it is. But what happened in the US in the 80s, 1980, 1990, they have huge farms, and they were doing sampling and then applying fertilizer. Then they realized that if you could probably take care of this variation and apply fertilizer as per the requirement at the site, probably you'll be able to save a lot more fertilizers, or at least get terms. So I'll just show you what this field variability is all about. See, how do you manage that? So there are three types of variability. One is the spatial variability. We all know that as we move around in the farm or in the field, there will be a variation in the physical, chemical, biological properties. Okay, from each spot. Then there is temporal variability. That means changes that occur during the growth period. You all know plant is taking up nutrients. And then over the years, the extraction of nutrients is different. And then there is one predictive variability. What this means is, in spite of doing the best management practices that you are aware of and doing, you find that the yield is still less, or it is not what you expected. So then what is the reason? What caused all that? That is how you try to find out the reason. So this technology is what we call as precision farming, where you can take care of this variability. Earlier it was, as I said, basically this precision farming, Pierre Roberts is called the father of precision farming. It started with the soil fertility management, so soil crop, site-specific crop management. But then people thought that it is something which can only be done at the large farms as in USA. But it's not like that. It can be applied at a micro level. That means the individual farm level in situations like our country, where we have a large majority of small and marginal, and I'll explain that how it's possible. Okay, now this is just to show, this is one field where you can see the available nitrogen variation. This field was supposed to be uniform. So the minimum was 152, maximum was 213, right? And this is for phosphorus, again, available P between 28.4 to 68.7. And this is for phosphorus, where the variability was even higher from 170 to 491. Now, this is kg per hectare, and this is these fields were supposed to be uniform. Okay. Now, if we take the average value, that average value will be occurring maybe may not be occurring at all in the field, because you've taken maybe whatever number of samples are there, and then you have taken an average, and it gives this. So what happens that now if suppose whatever average you work out and you apply, what it implies is that you in the field, because of this variation in the fertility level, maybe P and PK, you are going to apply either excessive or underdose in most part of the field. There will be maybe a few spots in this entire field where the average value would be matching the average value that you have worked out. The actual value would be matching the average value. So this is what happens. And this is just an example I like to give you that this is a soil test report of a field, of a particular field, where the measured parameters pH, phosphorus, and K2, P25, K2. And this was the difference in the mean. And this is, of course, in terms of quantitative. Here is in percent terms. I'll go to the next one. And so this is 7 samples were taken. Let us say 7 fields there, and there were 7 spots. This was the pH variation. This was the measured value. And this was the, for P, this was for K. You take difference from the mean. That is the mean value of this. This is the mean value here. And these are the differences in the pH values, P25 and K2, in terms of quantity. And this is in terms of mean, in percentage terms. Now, if you look at the fertilizer, shows that based on the average value, this was the fertilizer applied in all the places. Okay, and this shows the difference from mean. So if you correct this variation, you see this is the fertilizer which is required actually. So this was required more fertilizer, right, which was being under fertilized. And similarly, you had this case where it was over fertilized. The requirement was 1520, 1884, 1474, but you were applying all this. So when you look at this variation, you can understand that all these things, there will be difference in the production. Even excessive fertilizer doesn't help, and deficient fertilizer also doesn't help. And overall difference in kg was only 118 kg out of this for actually applied. So cost-wise, it wasn't much. It was non-significant, but this affected the yield to a very large extent. And that is why when we talk of precision farming means site-specific nutrient management, and then this is what we should be doing in our conditions also. How can we do it? In US it is possible because they have large fields, they have machines and all that, but we can also do it. Now, okay, now this is again another problem. We all have heard about the plow layer, I have a thin compacted layer which is formed in the soil, which affects the root growth and all that. So here you can see the K wave values. 1 to 6 centimeter is the okay. So where we show that probably here, this is the zone where the difficulty is there, water is not there, penetrating down, or the roots are not able to grow. Now, if you had this field and then you had to say, okay, you have to chisel. Chiseling means you need a plow which will go to below 30 centimeters, right? This is the layer. That will be requiring heavy machinery plus a cost. But if you look at this, this is the only patch which requires it, right? You don't have to do the entire field because the rest of the field is okay. So only this part. So you can save a lot of money, time, and everything when you do the operation only in this part. So this is why this becomes very, very important when you talk about field. So now, just to sort of summarize why we need all this. These are the water saving technologies that we say. I mean, we generally in India consider drip irrigation as, but what I said was you need precision leveling followed by adoption of scientific design check basins, border strips, land configuration, that is ridge and furrow or raised sunken beds. For micro irrigation, don't. It is about 17 million hectares now. And the target set in September 2020 was that they will have 10 million hectares in 5 years. Actually, it's about 1 million hectares which they're able to do every year. Precision farming is, different terminology. It started with site-specific crop management. As I told you, it is the fertilizer application US which created this. Now, of course, it's called climate smart agriculture, reducing the poor, and all these things, right? Basically, it means you are applying the right input in the right amount, right time, right place, and using the right technology. And that is why the efficiency is increased. And these are why in India, if you look at irrigation command, they are spread over large areas. Watersheds are not easily accessible, low input efficiencies, lot of degradation is occurring of natural resources, which is occurring to global warming. Farming has to be technology based for its viability. Now we realize that we have to take consideration of the climate impact. And as we go now, it means for the same productivity, we need to have more water, more nutrient requirement, more and newer pests and diseases they have to be tackled. So precision agriculture, as I give you, these are the definitions. In India, normally now, they say that micro irrigation, drip fertigation is precision farming and site-specific nutrient management. But it's not so. In reality, it implies delivery of all inputs, including herbicides, pesticides, as per the actual site. And to generate this information, it will require a seamless merging of multi-source data through remote sensing, GIS, GPS, sensors, or whatever it is, and all these technologies. So, this is what it really means. As I said, in India, we are only confined to this, but it is possible to move ahead in India also, because now the government is promoting drone technology, right? So this shows that earlier, of course, the satellites were there for GPS. We had planes covered. The resolution was very coarse. But now with the drone technology which the government is pushing, these drones can carry all those sensors which the satellites used to first take, or the plane used to carry on board, and all these can be taken by this. And you can combine with the ground-based sensors, for example, for fertilizers or for water and all that. And drones have a resolution. In fact, you can say a drone is a satellite in hand. You can monitor all those things over your field. It will just take a few minutes to do the entire job. And you can then do whatever you want in the. Now, what you need is a variable fertilizer adapter was the one that was earlier, variable rate applicator. Now there are variable applicators which can be taken up by these drones, and they are available for water, for fertilizers, for herbicides, all those inputs. In India, there are some places where they have it for fertilizer applications, still not for this. We are spraying these using drones for nano urea, pesticides. But as I said, there are variable rate applicators in operation in India, very, very limited. But as I said, this is a tractor based, but we have now in India some private industries which have these rate applicator. Of course, it needs to be popularized. How effective these drones are, this is just to show you that in an experimental field, you can find out the water stress of each field. Okay. You can even, okay, yeah. What happened? Okay. So what this shows is that each field you can find out what is the water stress of that particular field, right? Which means that these are experimental fields. So obviously it is very easy to find out the variation in the moisture stress condition in a farmer's field, however so small holding that farmer may be having, right? Now, and this is for the crop nutrient management. You can see that each field can be monitored for the different stress levels, right? So, is through drones, the message that I want to give is that government is promoting use of drones. We must go beyond the spray of pesticides and fertilizers. They must be used for that, no doubt about it. But probably it's time that we start thinking very seriously how to use these drones so that we can probably go in for precision farming. And that will make a big difference on the efficiency of the inputs that a farmer is giving. All you need, see, the government is promoting FPOs, government is promoting cooperatives. The farmer doesn't have to get trained in all. They can have one person train a youth who's familiar with these things. Even a 12th pass person can do it, or a graduate can take care of it. And then they give the advisories to the farmer. Drones, it is just to highlight that it's not only that we have. Drones can be for many things: soil moisture, nutrient status, crop health monitoring, fertilizer application, pesticide application, livestock management. You can see where your livestock is going. They can also serve as geofencing, where which is beyond your farm, within your farm, and all that. It can be used very. Of course, there are advantages: security, high efficiency, fine resolution, low cost. If you have a drone, you can run it even the same day, and the processing of time is very, very reduced. You can get your data. Maybe for some data you may get only in a few minutes or half an hour and 1 hour. So you can take a decision which you call as a real time software. Some companies have brought in for pesticides and all that, where you can do it, but then probably you need to do that. But there are some limitations, connectivity issues, in the sense that we all know that when you go out, move in the fields, internet connectivity can be an issue. Weather dependent, of course, because a small equipment, drone, it can only work under normal conditions. Extreme conditions will be difficult. And of course, it requires knowledge and skills, which I mentioned. So you can train people for that. Okay, so this is just to give you that drones can be used for many things. You can pest, disease, weeds, pesticide, fertility data, irrigation. And one very useful thing can be done is for the crop insurance. It can give you the exact situation on the field, on the ground in a few minutes. Even damage to crops from farm machinery can be visualized with that. And you can also rotate crops. I mean, a lot of applications are there. Survey fencing, monitor livestock. I think can be done with drones. Of course, you need a trained person. This is just a hypothetical situation that probably at some time we can think of these things. There you have your this, of course, combining all this because you want to represent it a integrated farming system. It is possible to have sound monitoring, wireless monitoring, camera monitoring. And of course you need and when you have AI and MLM tools with you, the information has to be connected. This behavior can be observed, whether it's poultry, cow, livestock, or pigs, or goats. Even fish can have an underwater camera. So the data can be processed, and then they will tell you that, oh, this is the problem. And then the advisory we can to the farmer that you please take care of this. And a lot of pilot projects have been done on this. Now, there's another issue which is talked about. Just Mr. Ajay, we'll have these questions at the end, or
Yes, sir. We have the queries at the end of the session.
if anybody wants in between, I have no problems in answering, of course, but they have to raise their hand or something like that. Okay, so then a lot of issues being talked about on having nature-based solutions now. So what are these nature-based solutions? That you must focus upon these. Basically, it means that there is synergy between the ecological integrity and food production. That means the ecosystem, the ecology of the place and the food production. What are the benefits? If you have nature-based solutions, it improves water efficiency, enhances biodiversity, soil health and restoration, emission reduced, and resilience. And the best advantages, they align with the global goals of sustainable intensification and climate adaptation. So these are the end. That's why people talk about. I will just, though I have slides so, but I'll give a very quickly go through some of them. So see, the soil health card, which is there now, why I want to raise some other issue, is basically a soil fertility card. So only has nutrients, which are estimated. But then when you talk of soil health, it is physical and biological both, right, which are important. Physical, uh, chemical, physical, and biological. In biological, estimation is a bit tricky because you have to analyze the samples immediately once you
Hello, Dr. Pooja.
Yes, sir.
I think sir have lost the internet connection. Okay,
Okay.
participants, Dr. Anil भी join करेंगे हमें. So please have some patience and be there for 2 minutes. Okay. Okay. Till that time, you can send your queries in the chat section if anyone have any queries. And उस समय तक आप पानी पी सकते हैं, है ना? Okay. Till that time, Dr. Anil Kumar join us. Can we have little bit interaction with our students whoever are here? तो जो भी हमारे यहाँ पे विद्यार्थी हैं, हम उनसे बात करना चाह रहे हैं थोड़ी देर. Let's see if Dr. Anil have joined us. Okay, Dr. Puja, let me know once he joined. Okay. So till that time, I want to interact with the students. Like, how is this course going, and are you people learning something? Please raise your hand. Who want to speak and interact? Please raise your hand. Okay, Kishan Kumar Raghuvanshi ji. हाँ जी.
Hello, sir. Good evening.
Good evening. How are you, Krishna?
Fine, sir. How about you?
We are also doing good. हाँ जी, बताइए.
First, thanks to you for getting me opportunity to talk with you, and thanks for Agri Sarthi, sir.
Thank you so much. आप
And,
यहाँ से क्या सीख पा रहे हैं, and how this is different from your regular degree education or studies, like what different you are getting over here on this platform?
सबसे बड़ा एक्सपीरियंस तो ये है कि we have to talk the one of the best teachers, professors in our fields. I think it's more bigger opportunity because when we study in any institutes, we don't get at option to talk like that professors. So I think it's bigger opportunity for me, and I feel very thankful to you.
Okay, thank you so much. Okay, is there any suggestion you want to provide for any improvement?
सर, मैं डेली फीडबैक में भी ये सजेशन देता हूँ, आपको भी बोल दे रहा हूँ, थोड़ा सा हिंदी का अगर मिक्स होता तो और अच्छा लगता इसको जो सेशन में, बिकॉज
Okay.
बेसिकली मेनी स्टूडेंट फ्रॉम हिंदी रीजन. सो इफ इन सेशन इन लेक्चर्स वी टीचर्स आर इन्वॉल्व सम हिंदी पोर्शंस,
Okay,
so it's
great.
more interesting to listen.
Okay, got it. So we will take care of it from next time. Okay, don't worry. Thank you so much for your suggestion and your compliments. Keep learning and keep growing. Okay, next we
Okay.
move to Sri Krishna Sindhaji. I think Dr. Sri Krishna is there. Please unmute. Hello.
हाँ सर, आवाज
Yes,
आ रहा है
please.
मेरा?
जी जी डॉक्टर साहब आ रहा है.
हाँ, मैं शिंदे एसएस हूँ, मैं प्रोग्रेसिव और इनोवेटिव फार्मर हूँ सर. ये
जी
सेशन
जी.
इतना अच्छा चल रहा है सर, फार्मिंग कम्युनिटी के लिए बहुत अच्छा चल रहा है सर. और जो एक्सपर्ट है, ये यूनिवर्सिटी में एक साल में नहीं मिलती, इतनी आप शॉर्ट पीरियड में ला रहे सर. बहुत बहुत अच्छा सेशन है आपका, कॉन्ग्रेचुलेशन सर. और जो भी नया टर्म है इंग्लिश हिंदी में बहुत अच्छा है सर. ये इतना नॉलेज है, मैं तो इसको ये आगरी सारथी का कुंभ मेला समझता हूँ सर मैं. हाँ.
जी जी.
और मैं ऐसे जोन से हूँ सर. ये इंडिया इंडिपेंडेंस मिलने के बाद 13 महीने में ज्वाइन होगा हूँ. और तुमने ये इतनी अच्छी फैसिलिटी हमारे लिए दिया है, इतना प्लेटफॉर्म दिया है कि इसमें हम जो हमारा मराठवाड़ा जोन आता है उसमें भी आपने नॉलेज का ये जो इंसाइट दिया है, ये बहुत आपके लिए मैं धन्यवाद देना चाहता हूँ. बस.
थैंक यू थैंक यू. आपका बहुत बहुत धन्यवाद श्री कृष्णा जी. और
थैंक यू
डेफिनेटली ये
सर,
जो,
थैंक यू.
हाँ, ये जो नाम आप देख रहे होंगे एग्री सारथी, ये सिर्फ एक प्लेटफॉर्म नहीं है. दिस इज द थिंग दैट यू ऑल हैव टू बिकम द सारथी. ओके, जैसे अ, श्री कृष्ण और अर्जुन जी की आपने कहानी सुनी होगी महाभारत की, इस तरह से आपको
यस
कृषि
सर.
के सच्चे सारथी बनना है आप सभी को. ठीक है, हमें भी
ओके
आपको
सर.
भी. और किसानों को एम्पावर करना है, यहाँ से सीख करके उनका जो है
बिल्कुल
किस तरह से
बिल्कुल.
फायदा हो उस पर काम करना है. और अगर
थैंक यू
आपने
सर.
बहुत बहुत धन्यवाद श्री कृष्णा जी. और आपने देखा होगा कि जी क्रांति जो नाम है हमारा, नॉलेज रिवॉल्यूशन इन एग्रीकल्चर, नर्चरिंग टेक्नोलॉजी एंड इनोवेशन. तो हमें क्या है कि ट्रेडिशनल जो कन्वेंशनल चीजें हम इतने सालों से करते आ रहे हैं और वो जो प्रैक्टिस चल रही हैं, उनके अलावा जो हमारे नई चीजें आजकल हमारे पास हैं, जैसे एआई है एंड ड्रोन टेक्नोलॉजी है और जो डिफरेंट एग्री एंटरप्रेन्योरशिप है, उनको सीख करके और हमारे जो अन्नदाता हैं उनकी इनकम को हमें एनहेंस करना है. देखिए सरकारें आती रहेंगी जाती रहेंगी, पॉलिसीज बनती रहेंगी, लेकिन उनको इम्प्लीमेंट करने वाले आप और हम हैं.
बिल-
ठीक है.
बिल्कुल
आप
सर.
लोग, हाँ, आप लोग सीखेंगे, उसके
चलिए.
बाद आप उनको इम्प्लीमेंट करेंगे. और फार्मर जो हमारे, आप खुद प्रैक्टिस करेंगे या फिर आपके घर में कोई होगा फार्मर, आप उनकी हेल्प करेंगे इन चीज़ों को प्रैक्टिस करने में, तो डेफिनेटली उनकी इनकम डबल भी हो सकती है, उससे ज्यादा भी हो सकती है। ठीक है, सरकार के नारे होते हैं कि हम जो फार्मर्स की इनकम डबल करेंगे, लेकिन काम हम लोगों को करना होता है।
बिल्कुल सर, बिल्कुल।
डेफिनेटली जो है
और
हमारे स्टूडेंट्स है, दे विल आल्सो वर्क ऑन दिस एंड दे विल डेफिनेटली लर्न सम न्यू थिंग्स एंड टेक्नोलॉजीज एंड दे विल अप्लाई टू एनहेंस द लाइव्स ऑफ फार्मर्स। सो थैंक यू सो मच श्री कृष्णा जी। अभी आई थिंक
थैंक यू
पीयूष
सर,
कुमार
थैंक यू
जी।
सर।
ओके, थैंक यू। अभी पीयूष कुमार जी कुछ बोलना चाह रहे हैं। ओके, पीयूष कुमार, प्लीज अनम्यूट।
Good evening, sir. Thank you for this thoughtful effort. Sir, I have one suggestion. Kindly, sir, send the same PPTs from our speaker sir से कि मतलब वो हमारे पास आता तो सर जैसे हम लोग अभी स्टूडेंट हैं मतलब नॉट अ फार्मर, तो कुछ चीज़ें रह जाती हैं जो हम एज अ स्टडी मटेरियल टाइप उसको यूज़ कर सकते हैं। जैसे सर उस दिन बी कीपिंग की जो क्लासेस हुई थी वो उसकी जो पीडीएफ थी पीपीटी थी वो बहुत ही मतलब अच्छी खासी थी। और उसके पहले नेचुरल फार्मिंग की। तो सर मैं ये चाहता हूँ कि पर डे की पीपीटीज हमें मिल जाए ताकि हमें एग्जाम में भी हेल्पफुल हो और बेटर तरीके से समझे। बाकी सर लैंग्वेज से कोई बैरियर नहीं है और अंडरस्टैंडिंग ठीक है, क्वेश्चन पूछने का भी मौका मिला है मुझे 2-3 दिन। बाकी सब बढ़िया है सर, बस पीपीटी हमें मिल जाए तो सर बढ़िया होगा।
ओके, आपका जो सजेशन है डेफिनेटली वी आर वर्किंग ऑन इट। और आपको जो पीपीटी है एज ए रीडिंग मटेरियल पीपीटी भी मिलेगी
जैसे
इसके
सर
साथ
आज
में।
भी।
हाँ जी, हाँ जी पीयूष जी, इसके साथ में आप लोगों को स्टडी मटेरियल मिलेगा। प्रॉपर जो एक मैनुअल होती है इस ट्रेनिंग की, वो आपको दी
ओके
जाएगी।
सर, ओके।
क्योंकि आई थिंक यू पीपल आर अवेयर अबाउट देयर विल बी ए एग्जाम आउट ऑफ दिस ट्रेनिंग प्रोग्राम। ओके, सो हम उस
यस।
चीज का ध्यान रखेंगे बच्चों। वी विल टेक केयर ऑफ दिस थिंग, डोंट वरी। यू विल बी प्रोवाइडेड विद द PowerPoint presentations as well as the reading material, then only you will be in a condition to learn and appear for the exam. Okay, तो वो करेंगे हम लोग। थोड़ा सा समय लग सकता है चीजों को अच्छा बनाने में, ठीक है। कि
ओके सर,
जैसा
ओके
हमें
सर। मैं
मिला वैसा भेज दिया तो शायद आपको भी थोड़ा ठीक ना लगे, हम उसको अमेंड
ओके सर,
करते
तो
हैं।
ये तो और अच्छी बात है कि आपने उसके लिए
हाँ,
पहले से प्लान कर रखा है कि हमें पीपीटीज देनी है।
बिल्कुल।
तो सर ये ठीक है सर, बाकी सर ऑल गुड सर, बढ़िया
ओके,
मजा
ओके,
आ रहा है।
थैंक यू सो मच पीयूष जी। आप सीखिए और अपने साथ वालों को भी सिखाइए, ठीक है। आई थिंक
बिल्कुल।
बादल जी वहाँ पे है। थैंक यू।
सर मैं एक और चीज चाहूंगा कि इस ट्रेनिंग के बाद आप एक कन्वोकेशन यानी कि कॉन्फ्रेंस अगर अरेंज कर देते तो ज्यादा ही
इट इज
बेटर होता
देयर,
सर।
इट इज देयर।
ओके
ओके।
सर।
हाँ,
थैंक यू सर।
हाँ, आप जिनसे जुड़े हुए हैं वो बहुत अच्छी जगह पे और बहुत सही लोगों के साथ में जुड़े हुए हैं, तो इन चीज़ों की मत सोचिए आप। बहुत कुछ अच्छा मिलने वाला है आपको, ठीक है। लर्निंग्स के साथ साथ बहुत चीज़ें मिलेंगी, ठीक है। एंड वी आर
थैंक यू
नॉट
सर।
लिमिटेड टू अप टू दिस ट्रेनिंग प्रोग्राम, वी आर ऑल्सो अवेलेबल आफ्टर दिस ट्रेनिंग। ओके, whenever or wherever you want any type of help related to farmers and improving the farming community. Okay, we will be always there for you people. It's not about the certificate, it's not about exam and what your participation, it's about the change you can bring in the farmers. Okay, so whenever you find any type of difficulty or any type of opportunity and you want to discuss with the experts or our team, we will be available for you. Okay. Yes.
ओके सर, ओके, थैंक यू
Okay, thank you, Piyush. uh, Badal, please unmute and give your feedback and your suggestions.
नमस्ते सर। सर बादल
जी
सर, हम
नमस्कार।
बिहार के रहने वाले हैं सर।
जी जी।
बिहार के रहने वाले हैं सर, और विगत 9 दिनों से सर हम लगातार यहाँ से सीख ही रहे हैं सर। लेकिन कई सारी ऐसी चीजें हैं सर की जो कि प्रैक्टिकली एप्लीकेबल नहीं है। पिछले 7 दिनों में, पिछले 9 दिनों से में सर 2 ऐसे क्लास हैं। एक दिन डॉक्टर बलजीत सिंह सहारन आए थे, और कल जो हर्बी साइड पर जो लेक्चर लगी थी वो काफी सर अच्छे थे। प्लांट प्रोटेक्शन के सर कुछ और लेक्चर्स अगर आप लगा देते जिसमें हर्बिसाइड या पेस्टिसाइड के सर, जिसमें यूज कंट्रोल मेथड वगैरह ज्यादा रहते हैं, और प्रयास सर किया जाए कि जो चीजें प्रैक्टिकली एप्लीकेबल है सर, बहुत सारे लेक्चर ऐसे लगे हैं जिसको सर हम फार्मर सर नहीं यूज कर सकते सर। ठीक है सर, वो थ्योरेटिकली के लिए अच्छा था, पर प्रैक्टिकल के लिए सर प्लीज 2-4 क्लासेस और हर्बिसाइड और पेस्टिसाइड्स के जो एक्सपर्ट हो उनसे लगवाएं सर।
ओके, बादल जी, आपका जो सजेशन है बहुत ही अच्छा है, और हैंड्स ऑन ट्रेनिंग की आप जो बात कर रहे हो कि आप आपको प्रैक्टिकल चीजें भी बताई जाएं इसमें, तो डेफिनेटली आपको बता दें कि जो हमारे एक्सपर्ट्स हैं, ठीक है, आपने अगर ब्रोशर अच्छे से देखा होगा तो उसके अंदर हमने मेंशन किया हुआ है कि देयर विल बी सम प्रैक्टिकल। ओके, और जो हमारी पार्टनर यूनिवर्सिटीज हैं लाइक यूएस रायचूर है, बीसीएस यूएचएफ पौड़ी गढ़वाल एंड दिस बीईटी बांदा, देयर विल बी सम प्रैक्टिकल्स by our experts or our delegates regarding natural farming and all the different topics we are going to discuss. And जो आपने बोला प्लांट प्रोटेक्शन से रिलेटेड इन फ्यूचर जो हमारे टॉपिक्स होंगे, उसके अंदर जो है अभी 30 दिन है, तो उसमें से हम शायद 7 और 8 दिन कंप्लीट किए हैं, तो पूरा महीना अभी बाकी है। ठीक है, तो सारी चीजें कवर कराई जाएंगी, और डेफिनेटली आप जो है अच्छा जो है यहाँ से सीख सकते हैं। यू जस्ट नीड टू हैव सम पेशेंस एंड लर्न डेली। ओके, अभी जो है डॉक्टर अनिल आई थिंक ज्वाइन कर चुके हैं। All right, so he is about to join, so I think we have got some information in the chat section also. Okay, Venkata is saying we are learning a diversity of agricultural sciences knowledge. Thank you, sir, for providing this wonderful opportunity. So thank you so much, Venkata. And okay, Simi Tanya is asking about, can you answer the questions which are posted in feedback form? Yes, we will answer, Simi. Don't worry. The questions are being asked just to answer and enhance your knowledge. Okay, these are not just formalities. इसलिए जो आपका feedback form है, that is mandatory and you need to fill it daily. And your guys are doing great. Great. Okay, thank you for your compliments, Simi. Dr. Anil will answer your queries, so please be there. Okay. Anand Dev is saying thank you, sir. इस प्लेटफॉर्म के माध्यम से जानकारी देने के लिए, आपकी इस ट्रेनिंग के माध्यम से हमें फार्मिंग के काफी ज्यादा चेंज लाने में मदद मिला। तो स्टूडेंट्स, वन थिंग लाइक वी हैव लॉट ऑफ कॉम्प्लीमेंट्स ओवर हियर, सो दैट्स गुड, बट द वन थिंग वी विल आस्क यू टू डू, जो भी आप यहाँ से सीखे उसको इम्प्लीमेंट जरूर करना है। ठीक है, आइदर इन योर ओन फील्ड्स, इन योर ओन फार्मिंग, एंड wherever you go, just interact with the farmers and know their problems and try to resolve those। ठीक है ना, ये पढ़ के जो usually whatever you are doing in your regular degrees, please don't do that। यहाँ से जो आप सीखे उसको अप्लाई जरूर करना है। ठीक है, so now I think Dr. Anil Kumar have joined us, so thank you so much for your compliments। We have a lot of compliments in the chat section। Okay, and definitely there will be some suggestions, I will go through those। So uh, I request Dr. Anil Kumar Singh to please continue the session। Dr. Sir, am I audible to you? Hello।
हाँ बताइए जी, कहाँ रुके, कुछ आइडिया है?
हाँ जी डॉक्टर साहब,
कहाँ रुके थे?
अपन पेज नंबर 68 पे थे डॉक्टर साहब।
एक सेकेंड ना,
आज स्टूडेंट्स थोड़ा सा लेट हो जाएगा, लेकिन ये जो टॉपिक है बहुत ही ज्यादा इम्पोर्टेंट है। इट इज द मोस्ट इम्पोर्टेंट वी कैन से। ठीक है, तो सोयल है वही, अगर हमारी उसी की जानकारी हमें अच्छे से होगी, देन ओनली वी विल बी एबल टू फर्दर स्टडी अबाउट द क्रॉप्स एंड देयर रिक्वायरमेंट्स एटसेट्रा। ओके, सो ये जो टॉपिक है और इनको जस्टिफाई करने के लिए जो डॉक्टर अनिल कुमार सिंह है, वी हैव विद अस, ही इज द reputed scientist। Okay, so welcome back, Dr. Anil, and we can continue
आपका
with the session।
विजिबल है ये?
Yes, sir, it is visible।
यही यहीं पर रुके थे क्या?
I think पेज नंबर 68 पे थे डॉक्टर साहब।
let me see. Okay. इनका यही होगा फिर। अब बता सकते हैं कहाँ रुके?
पीयूष कुमार जी बताइए, यहीं थे, कहाँ थे?
नहीं सर, इससे भी हम 2-3 पेज आगे ही थे सर।
आगे आगे
जी सर।
ये हो गया था।
हाँ सर, ये भी हो गया था, आपने बताया था कंपैरिजन। ये भी हो
ये
गया था सर पेज। ये भी
अच्छा
हो गया था जिसमें आपने बताया था कि
हाँ,
कैसे
ये
कैप्चर।
भी हो गया, ये भी हो गया था,
हाँ सर, ये भी हुआ था।
ये वाला।
एक मिनट सर। हाँ सर, इस आपने ये बताया था कि क्या क्या ड्रोन से एप्लीकेशन कर
हाँ
सकते हैं।
हाँ, ये इसमें तो लिमिटेशंस हैं।
हाँ, ये भी एडवांटेज एंड लिमिटेशन भी हो
अच्छा,
चुका था
ये
सर।
ओवरऑल।
हाँ, यहाँ से आप सर कंटिन्यू कर सकते हैं, इसमें ही थोड़ा बहुत छूटा था।
अच्छा, तो this is just a summary of what we have been talking about drones, how we can use it for agriculture purposes. So my main message was that we are using drones for spraying of pesticides and nano fertilizers, but there is a lot of scope. And the reason I said was that the drones that are available now can use any of the sensors for detecting pests, diseases, whatever it is. So this shows that the potential of drones should be utilized, and they are more relevant under Indian conditions because of the small farm holdings. The advantage is that इसमें तो हमने दिया इरिगेशन का सब एक वन एडवांटेज इज दैट जो हमारा क्रॉप इंश्योरेंस स्कीम है, फसल बीमा योजना, drones can give the exact situation at the ground level फॉर वेरिफिकेशन एंड ऑल दैट। क्योंकि जब भी कुछ होता है तो देर आर, जैसे हेल स्टॉर्म का होता है, सो देर इज ऑलवेज इन स्मॉल पॉकेट्स, ये नहीं एक फार्मर का पूरा डिस्ट्रॉय हो जाएगा क्रॉप एंड द नेक्स्ट फार्मर विल हैव नो डैमेज। So for to resolve these issues, I think that is one again a very good advice. So other things I was just mentioning, right? So this is just an overall ki, what I was saying is that in future when we come to integrated farming system, it is possible. Of course, you need a very strong database for using uh, these AI and ML languages. Uh, जो आपका बिहेवियर पैटर्न होता है ना, जैसे बिहेवियर ऑफ हाउ पोल्ट्री विल बिहेव if it's not healthy, if it's too hot or too cold. Likewise for animals, and you have monitors, sound monitoring का है, उनका behavior में wireless monitoring है, camera monitoring है. This can give you a situation, what is really happening, and it has been tested in many places. It's not that we are doing. Probably अभी हमारे यहाँ एक्वाकल्चर में इतना नहीं हुआ है, but globally it is there. All these things can be fed, and then you need data. All this processing of data will require uh, software. No issues with that. Converting that into an advisory for the farmer, you need one precision farming service provider who will integrate all this information, and the farmer can get the uh, advice on what is to be done depending upon how these animals are behaving. So this is futuristic, but probably the way we are moving, this probably would become very important for all of us. We have started drones का शुरू किया है, but I think you can go ahead and do डेयरी फार्मिंग में थोड़ा बहुत काफ़ी इनमें से रेडियो फ्रीक्वेंसी वाला वो यूज़ कर रहे हैं, RF टेक्नोलॉजी, RFI टेक्नोलॉजी जो हम लोग यूज़ करते हैं, दे आर यूजिंग इट मैनी प्लेसेस. Then probably this was where I was, this important that I would like to say. Lot of focus is there on why nature-based solutions. हम लोग जो करते हैं तो थोड़ा रहता है कि भाई आजकल मॉडर्न टेक्नोलॉजी जो है वो काम नहीं करती है, देयर आर सम प्रॉब्लम्स with that technology. So why should we focus on nature-based solutions? The reason is there's synergy between ecological integrity and food production. The benefits are multiple. You have both water use efficiency, biodiversity improves, soil health restoration, reduce emission, and long-term resilience. Because you are trying to not trying to change the path of nature, just helping the nature to help you in conserving all these things. And then the most important thing is that nature-based solutions help you for sustainable intensification and climate adaptation. Now, and I was also mentioning that in soil health card that the government has is now currently is doing uh, every 3 years for each farm holding. This is essentially a soil fertility card. I mean, in the sense that it is only focusing on the fertilizer part, the nutrient part. But then in a soil health card, you need both three things: soil physical, chemical, and biological properties. Biological properties, there's a bit difficulty in immediately measuring it. You have to bring the samples from the field and then do it in the lab. But you can have a fairly good estimate by the active carbon, the soil organic carbon content for microbial properties. But it is possible. I think with time, it will be possible to even monitor that. Physical properties, I mean, earlier, if you remember, these I mentioned here: structure, porosity, bulk density, infiltration rate. Earlier, bulk density, porosity, infiltration rate, texture, they were being monitored regularly in the basic, but they stopped somehow. Some of these, texture, it's a one-time measurement. You don't require to measure it every 3 years. Structure is one important thing because the structure influences the availability of nutrients available and how whether the roots will be able to penetrate, how the environment for the microbes. So all these things are important, and this is why I utilize this to say that you should include this as a part of soil health card. And then just to give some results, I took some results from but I will not go into these individual projects. I will just summarize them, right? So these are different studies which were conducted in of these projects. Like I think many of you must have heard of Hivare Bazaar, Tralegaon Siddhi, Alwar Johad, Organic Mission, Karnataka watershed programs. What they have indicated is that landform specific interventions work best. जिसको हम लोग लैंड कॉन्फ़िगरेशन भी कहते हैं, कंटूर ट्रेंचेस हैं, बंडिंग है, वेजिटेटिव बैरियर्स, they improve infiltration, reduce runoff on slopy terrains. So this is a nature-based solution for your for runoff and all that. Plant root systems, they are powerful physical engineers. For example, agroforestry, grasses, deep-rooted cover crops, they reduce the compaction, they enhance macropores, and they stabilize aggregates, which again make everything, the soil physical environment very conducive for plant growth. Water harvesting, I think, if you remember, I mentioned that India has 1/5 per capita water storage compared to China. And water is one resource which makes a big difference to a farmer. And considering the uncertainty with the rainfall, the change in rainfall pattern, water harvesting is very, very important, rainwater harvesting. It could be micro, mini, major, medium, whatever it is. Storage has to be increased. And once water storage is there, it makes a lot of difference to the system. Controlled grazing and community management is also very important so that reduces the degradation cycles. There's in Northeast where we talk about jhum cultivation, no? So how to reduce the degradation cycle. So it protects soil surface from trampling. If you protect that by trampling, then it accelerates regeneration. I have already talked about organic inputs with the strengthened structure and biological synergy. So that's why a lot of focus on organic farming, integrated nutrient management, natural farming. So just to conclude on this part of the soil health card, the soil health part is the importance of physical properties. And all these projects, these were centered to design of all these successful projects, right? And it's not only that it's only physical property like infiltration or porosity or bulldensity or aggregate stability. There are a lot of cascading effects of improved soil physical properties, better nutrient retention, enhanced biological activity, higher yields, and resilience to climate. So these are again benefits in addition to the improvement in the properties. And these nature-based solutions like afforestation, contouring, agroforestry, controlled grazing, uh, cover cropping, they work best. They have to be tailored to the local soil physical state. ये नहीं है कि these will work everywhere. You have to look at the erosion risk, the compaction, the moisture dynamics, and then choose any one of them. So these are just to highlight that physical properties are also very, very important in the soil health card. I will quickly go through this because so the way forward, soil testing and assessment is very important. Soil testing, we are already doing it every 3 years. So this gives us what is the requirement of the soil. But we need to increase the biological parameter and the physical parameters so that you can take a much better informed decision. You can have some visual assessment always. Soil conservation practices are very important, particularly as I said, erosion control. One of the most serious issues is erosion, soil erosion, and one has to do it. There are many control plowing terraces, a lot of strategic options are available. Cover cropping is there to prevent erosion. Nutrient management, we talk about balanced fertilization. See, normally chemical fertilizers are blamed. Basically, we say that balanced fertilization, if you follow balanced fertilization, probably will be able to do. And then in that, we say integrated nutrient management. If possible, 25% of the chemical fertilizers, if they can be replaced by an organic source, by biofertilizers, composting, vermicompost, or whatever it is. That will help the soil to maintain its natural. We also have something like a soil health gap, like productivity gap. So which is the ideal soil health condition and what is the present soil health condition? So with that gap, how that gap can be taken care of. Then of course crop rotation, a very simple way of improving the soil. For example, improving of legumes. We always insist that they should be added there. Water management, I think efficient irrigation, as I told you, the efficiency of our irrigation system is also about 30 to 40%. And it's very high in drip and sprinkler, so government is pushing them also. Rainwater harvesting, as I mentioned earlier, that rainfall uncertainty, so you have to harvest rainwater because the rainfall patterns have changed, the intensity has changed, so you have to though India is supposed to be having more rain because of climate change, but the number of rainy days would be less. The days with the higher intensity would be more. So that you have to harvest these water, otherwise they will cause more damage. And as I mentioned that we are having a lot of scope for rainwater harvesting because almost 30% of the water is going off as waste. Organic matter enhancement, of course, no doubt about it. Soil organic carbon is very important. If a single parameter has to be decided, it is the organic matter, soil organic carbon, which can tell you what is the condition. But that is why natural farming, organic farming is pushed. That also includes the soil structure improvement, which is again very important because structure affects a lot of other properties which affect the crop growth. And then biodiversity promotion is very important because it is more organisms mean soil is alive, and alive soil is what is required. So their beneficial organisms are there. As I said, most of these nutrients as such are made available by these microorganisms. So if you have less number of microorganisms, then the effectiveness of these is reduced. Earthworms are also considered as a good indicator that the soil is having good health. And normally people always say that this is one good parameter of. There are some quantitative values also associated, maybe 100 to 150 earthworms per square meter, up to 30 centimeter depth is a good indicator of good health. We have to, pollution prevention is important because many of these pesticides, herbicides, even fertilizers, they have some contaminants, and if you don't use them judicially, this pollution level is going to increase. Waste disposal is very important because many of these products have significant quantities. So one has to be very, very careful and do it systematically. To highlight the importance of soil health, education and awareness training programs are there. Community engagement is there because natural resources. It's not that if you can, if you have 2 hectare field and you do something here, it will improve. No, it will not. If the community engages in those management options together, the benefit is always much better because if I have a soil conservation measurement on, technique implement in my field, implement a particular thing, it will not make a big difference unless the whole village and they are combined together. We need a policy implementation. We are trying to convince the government. Government is also looking that there should be some incentive for the farmers who adopt best management practices or sustainable practices. Carbon credits is already there, which is systematically now being done. Government came up with green credits, which means that if you are able to improve the efficiency of the resource use, or you do something which is able to have a lesser impact on adverse impact on the environment, then you should be rewarded in terms of credits, and those credits probably can be converted into financial benefits. They are working on it, how to do it, but probably very soon there will be some methodology worked out with the farmer level. So, okay. So, coming towards the end of my presentation, I think I already exceeded a lot of time. The strong take-home message is that we cannot manage what we do not measure, and we cannot sustain what we do not monitor. So, and we cannot care for soils without integrating both into management. So that is why measure, monitor, and management is the message that we want to give you. So caring for soils has to have a framework which deals with the measure, monitor, manage. A lot of parameters are there in the soil health card I have mentioned here, which can be taken to monitor, and then based on the measurement, you can always do the management. One must remember that soil is a living dynamic system, and it requires to soil care requires evidence, that is how you measure something, continuity, that is monitor, and then management, that is the action part. So this is how the 3M framework links that is the measure, monitor, manage, to the diagnosis part, the dynamics part, and the decision that has to be taken, what is to be finally done. Soil management without measurement is guesswork. I think this you all realize. This is what we should be doing. I will just very briefly describe what the environment, the ecosystem services. This is being talked about a lot for the last several years. Not much has been done. Basically, there are 4 components in ecosystem. One is the provisioning, which is mentioned here. The other is cultural, regulatory, and sporting. What we are generally focusing on is the provisioning services. Provisioning means what is the food produced, what is the fish harvested, what is the wood harvested for furniture, how much fuel is being generated for ethanol, for example, and to which we can immediately attach a monetary value, right? This is one what you focus on. But if you do not consider the regulating services or the supporting services like nutrient cycling, soil formation, primary production, regulatory services like climate regulation, flood regulation, disease regulation, water purification, So if you ignore these, then probably you will not be able to sustain the production on the productivity level, the production level that you are doing on provision service. That is very important. These have to be valuation part is left, which is being done. So how do you give a monetary value to the supporting services or the regular services? Cultural services are basically aesthetic, spiritual, education, recreational. So they are also very important in the task. So this is what is being done for that. This is we are considering seriously, and I think there are a lot of publications now which focus on the evaluation part of these. And then, of course, we have this. These are some of these mentioned. I will not go into detail of that. What are the ecosystem services which the soils provide, the regulating and the supporting services, not the provisioning. So it helps in water regulation, water quality control, erosion control, cycling of nutrients, water, energy, biodiversity, biological control of pests and disease is very important. And habitat to sustain biodiversity is also equally important. So these all go under that. And then, of course, greenhouse gas storage retention. So all these go into it. So just to come to the last few slides. I think when I got disconnected, probably you didn't even hear anything, right? So take-home message is that man, despite his artistic pretensions, his sophistication and his many accomplishments, owes his existence to a 6-inch layer of topsoil and the fact that it rains. So this is the reality. These two resources are very, very important for our own existence. So we have to take care of them. World Health Organization defined One Health approach. This One Health approach came into the limelight because of COVID. So, but it has now been modified. One Health is an integrated, unifying approach to balance and optimize the health of people, animals, and the environment. It is particularly important to prevent, predict, detect, and respond to global health threats such as the COVID-19 pandemic. But basically, they have widened the scope now in the sense that One Health approach is particularly relevant for food and water safety. Right? Nutrition, the control of zoonosis is of course important. Pollution management and combating antimicrobial resistance. One example I gave was of the arsenic poisoning, right? It was again poor management of natural resources, which affects both animal and way back in 1940, we had Sir Albert Howard. He was a British scientist who came to India. When he looked at the farming practices of Indian farmers, he said that the health of a soil, plant, animal, and man is one and indivisible. So, which means that you cannot separate out. And I always mention that soil is the starting point. And I gave the example of arsenic. Many of these micronutrient deficiencies which cause diseases in us, it is microbial deficiencies. Zinc became very important during COVID. Likewise, for animals also, there are many diseases which are linked with the deficiency of micronutrients. So this becomes very important now. So at the end, I would say that for human race to survive, keep soil alive. Thank you very much.
Thank you very much, sir, for an insightful session grounded in scientific research and data-driven findings. The practical explanation and evidence shared today have greatly enhanced our understanding of soil care. We shall now move into the interaction and query session. Participants are requested to raise your hand if you wish to ask a question. When invited, please unmute yourself, briefly introduce yourself, then ask your question. You may also post your question in the chat box. Let's start the first questions today with Subham Saurabh. He is pursuing graduation from BHU. His question is, in India, mostly farmers follow traditional method and they grow mostly rice and wheat. How they can manage soil health conventionally and also by natural method?
Okay. Now, see, this rice wheat system is a very intensive system of cultivation. That is one. A lot of resources are there. And the government, why farmers are still pursuing it is because of the income that is being generated by the system, right? if you go by a scientific definition, probably nobody would recommend growing paddy in Punjab, right? Considering the soil and all those things. But markets, because farmers, see, they were the farmers who produced rice and wheat when the country needed it, right? The Green Revolution happened because of this Punjab, Haryana, and all these states. Now the question is how to shift. Government has been trying to diversify, but again, it's the economics which are important. So now the what is government is doing is they are trying to make farmers shift to direct seeded rice, right? So that there is less amount of pressure on the water, and they are giving incentives for buying machines which can directly sow the paddy in non sow, and also for switching over from transplanting to dry seeded rice. A machine plus otherwise also, in addition to the machine, which is 50% subsidy, they give some money. Haryana, Punjab, they give. Some states are doing that. This is the way they are doing it. Farmers, because it's a irrigated system, the income and everything is varies. The farmers are not willing to change so easily. Haryana tried to give farmers some incentive to grow maize instead of rice, but that was successful only a limited area. Dry seeded rice is showing some impact, and now there are certain agencies which have come up that if you follow better management practices, maybe they'll be able to get some these carbon credits. As I said, if you can improve the efficiency of your inputs, or increase the yield, or do something which is good for the environment, you will be getting some benefit. They have already started that in this right system. So hopefully something would be done. But yes, it is not so easy to shift. Not because of the farmers. Those farmers were willing to adopt new technologies. That is why the Green Revolution occurred. So until they find that something more, giving more monetary benefit is there, it'll be difficult to switch over. It's not because they don't want to change. They will change, and they are trying to. Dry seeded rice is one example, which is it is taking place though slowly.
Any other participants having any question, please raise your hand.
Okay, thank you, Daksha. Like what you have just told about the incentives. In Haryana, we have the Mera Pani Meri Virasat scheme, in which the government of Haryana is providing 8,000 rupees incentive to the farmers who are not growing paddy.
Yeah,
Okay,
yeah.
so such type of incentives are there in different states, mainly in Haryana and Punjab we can talk about. So thank you, Dr. for highlighting this. And we have one more question from Sneha Sundi, and she is agriculture graduate. Sir, can bioenzymes be as effective as other organic manures on growth of plants, and can it be used by farmers on field or not? Will it
Can
be
you
beneficial in any way?
can you repeat the question, first part?
Sir, it is about the like can bioenzymes be as effective as other organic manures on growth of plants, and can it be used by farmers?
Yes, biostimulants, are being now promoted, and the government is also, I think, encouraging it. They have permitted the use of biostimulants. Of course, there was some controversy over their use, but uh, biostimulants used properly will definitely have advantage. You know, particularly because it's a biostimulant, so we call it. It's a nature-based solution for whatever you are doing. So it will help. To what extent it can happen, I think that will take some time before you can come up with figures. Okay, that is so much percentage of fertilizers, or they have been able to reduce because of use of biostimulants.
Okay, thank you, Daksha. We have one more question from Bilal Ahmed. Please ask your query. First, you need to introduce and then ask your query. Bilal Ahmed.
Good evening, sir.
Well, please go ahead.
Myself Bilal Ahmed from Karnataka. Sir, my question is that recently from last 2 to 3 years we are facing the problem of soil hardening.
So,
हमारे यहाँ पे जनरली जो है
go
क्रॉपिंग
ahead.
पैटर्न शुगर केन और पल्सेस है. पल्सेस में जो है ना जनरली प्लोइंग जो है एनिमल्स के थ्रू करते थे हम लोग, लेकिन अभी फिलहाल जो है इट हैज बिकम ऑलमोस्ट इम्पॉसिबल थ्रू एनिमल्स सर. So how to tackle this problem of soil hardening, sir?
नहीं, देखिए ऐसा है ना कि आजकल सी लॉट ऑफ stress is being focused on two options. One is zero tillage, right? Conservation agriculture, where you do away with the tillage, or we say use minimum tillage. For example, if you want to sow a crop, so only have one row, just the insertion of those seeds for there. So that minimize tillage, right? And when I said soil physical properties, this is one important parameter, compaction which occurs. So there are alternatives how you can take care of these alternatives. Avoid heavy machinery movement, yes, and that is one which sometimes creates a problem when we talk of zero till, when you need to have heavy machinery. So it is becoming an issue. And in my talk, I also give an example of hard pan formation, which restricts root growth and water movement and all that. So there are ways and means of doing it. Minimizing tillage is one of them. And there are now options for almost all crops which you can do without. Of course, the machinery is required for that. And the government, I know in some states, they are doing custom hiring centers which will provide that machinery. Yeah, but minimum tillage is one of those conservation agriculture options which are being now promoted. In fact, world over, conservation agriculture is being done in rainfed areas. In India, it is mostly done in irrigated areas. Very little area is under conservation agriculture in the rainfed areas. But the scope is there, and it should be popularized.
Sir, another question is that you said about measuring the soil. In our KVKs,
Yeah.
generally we are not getting the actual values. They are just simply adding the values, sir, general values. When we provide them the soil,
See, this is what I'm saying. Yes. See, I made something very clear that measuring is very, very important, I think I focused on that many times. All KVKs, to my knowledge, were provided with soil testing equipment, right? Soil testing setups, equipment. I know. So and many of them earlier also had, for example, pH, EC, nitrogen, phosphorus, potassium measurement, they were there already. But then the micronutrients ke liye you needed something more sophisticated like an atomic absorption. Then they came up with a cheaper version of soil testing equipment, which is now available and much cheaper compared to anaerobic absorption. And they should be using it because see, that was earlier practice where, they will just write down this is the soil and this is the general properties. But we have to move beyond that. Otherwise, the whole purpose of having a soil health card, every 3 years is defeated if you are not going to measure that. Only then you will know what are the changes that have occurred and what would be the best dose of nutrient that a particular soil, depending upon the cropping, weather, and all that depends. So I think it is and since KVKs were provided, I think they should be taking it more seriously because I know government has given money for the sampling, for processing sample, testing it. It was provided to all. They will be provided through the soil health card mission. So they should do it because see, it's like why do we go to a lab for our own test when doctor says okay something is wrong with you, you please do these tests. So if those tests are not done properly, you will be affected. So you should think in those terms that the soil health card is supposed to indicate the health of the soil. So if that test is not done properly, probably you are going to whatever you do may harm the soil also. It's possible instead of doing good. So I think that is why it's important that should be done.
Sir,
Thank
my
you, sir.
question is that how to ensure.
How to ensure? How to ensure? I think now the person who is handling it, the KVK in charge, should ensure that these tests are done. See, it is the testing equipment was given with the expectation that you will be using it. You know.
Okay, thank you, Dr. Saab. So, with your due permission, as you are speaking from last 2.5 hours, so can we have 2, 3 more questions because students are very
Oh
interested
yes,
in
no problem, no problem. I got disconnected. I don't know, and I did not realize it.
Okay, okay. Thank you so much, Daksa. So there is a question from Siri Karini, and she is UG student from Telangana. Her question is, what can be the alternative ways to using high yielding varieties by the farmers since HYVs excessively drain up nutrients from soil, and if they don't use such varieties, the yield will decrease drastically. So what can be the better way to adopt for the better production?
See, one thing is that we say go in for integrated nutrient management. Number one, uh, and as a soil scientist, 20 if you can substitute those nutrients by 25%, right? Uh, by any organic source, maybe biofertilizer, maybe compost, maybe any source which is available. See, it is very important that that organic source should be easily available. So that will take care of the soil health, right? And also, I mentioned very clearly that the efficiency of these nutrient use is very, very low. There's a lot of potential of enhancing this nutrient use. For example, and why government went in for neem coated urea? That is slow release fertilizer, right? Now, because urea is so cheap because of the subsidy, but if tomorrow some government decides that we are going to remove the subsidy or reduce it, then you will automatically start. I gave an example of Bangladesh, you know, which is paddy soils and areas in West Bengal, Orissa, Bihar, they are like that. And but they are not the farmers are not adopting the technology because it's so cheap, you know. So that is important, that the efficiency part. Water soluble fertilizers are not given subsidy, but all those who are using drip fertigation, they are using those because there the efficiency is very high. As I said, you can say if you have drip fertigation, 40% savings in fertilizer, 30 to 40% direct saving in fertilizers, right? So one can go in for that. And as I also mentioned, any crop now you can grow using drip or sprinkler, any crop. The other option is going for raised bed system. Water use efficiency improves by 20% and your nutrient use efficiency also improves by almost 15-20%. So this will help in reducing the amount of fertilizer that you need to add. We have high yielding varieties. Now they are coming in biofortified. Now with the genome editing which technique which is available, they'll be able to come up with varieties which will be able to produce the same with less nutrients. So ultimately the cost would be, the input cost would be reduced for the farmer. So this is how we are moving ahead so that we all realize that these are problems, and I'm sure solutions will be worked out. Why I mentioned precision farming is, why? If you can, I gave one very simple example, the variability in a field. We do it on average value. Average value very rarely exists in a field, because you have taken 10 samples and you have come with one average value. Variability is very different. So if you can give, and as I said, variable fertilizer applicators, herbicide applicators are now available in the market. So if you do it, that itself will make a big difference. The cost would remain the same, but your productivity and yield would increase. So there are so many measures, but yes, improvement in the use efficiency of fertilizers and water, both is very, very important for us in general.
Okay, thank you so much, Daksa. And I hope it
Any other?
also. Yes, sir. We will have one last question for today. And this question is from Ankit Malhotra, and he is the postgraduate student of soil science from Punjab Agriculture University. And his question is, among nano urea and urea fertilizer, which one is beneficial for farmers and why nano urea is not much successful, especially in North India.
No, what was the first part of the question?
It was among the nano urea and urea fertilizer, which one is beneficial for farmers?
Okay. Now, let me tell you from my own personal opinion. See, nano urea is being sprayed, right? So it should be sprayed only when there is enough vegetative cover or the leaf growth. So you have to use a combination of neem-coated urea for the basal application, and then utilize nano urea once the crop is grown, then probably spray the nano urea. That combination is probably the best one for a farmer. This is my opinion, and because the initial at the initial stages where the crop when it's growing, it requires some nitrogen, and if you spray, it will be only going on the soil. There will be hardly any leaf on the plant. So that is why some basal application is required. A combination of both is going to be the best option for a farm.
Thank you so much, Dr. Pooja. Please conclude the session.
Thank you to all the participants for your thoughtful question, and sincere thank to Dr. Anil sir for addressing them so clearly. On behalf of the Agri SAARTHI team, I express my sincere gratitude to Dr. Anil sir for today's informative and research-oriented session on caring of soil. Sir's insight have added a strong academic and practical value to this program. I would also like to thank Ajay Kasana sir, Organizing Director and Chief Secretary of Agri SAARTHI, for his continued guidance and effort in ensuring the smooth conduct of this training initiative. My thanks to all the participants for your active involvement. I also extend my appreciation to the entire Agri SAARTHI team, whose consistent behind-the-scene effort make each session possible. A quick reminder to all the participants. The attendance form has been shared in the chat and group and will remain active for a limited time. Kindly ensure you submit it. Thank you for being a part of the Day 9 of Agri SAARTHI Kranti 2026. We look forward to your participation in the upcoming session. Thank you. Jai Hind.
Thank you, Dr.
Thank you,
Pooja.
and good night to everyone. It was a
thank
pleasure
you
to
so much,
interact with
Dr.
these students.
Yes, sir. Thank you so much, Dr. Anil, to bless our audience, and definitely it added some new ventures or the wings of the knowledge into the minds of our young professionals or the graduates. So definitely they will work on the caring of soils, and they will also help the farmers whatever they have learned from here. So thank you so much for joining us and blessing our audience. Thank you so much,
Thank you.
Dr. Anil, and thank you
Thank
so
you.
much all
Thank
the
you.
participants.
Thank you very much. I'm sorry for the delay that happened because of disconnection.
At that time, also the students were engaged, Daksa, no issues.
Okay. Thank you. Thank you. No, I actually did not realize when your call came only then I realized. Okay.
Yes, sir.
Anyway, these things happen, you know.
Yes, sir. Yes, sir.
Okay. Thank you. Thank you very much.
Okay. Thank
Good
you so
night.
much. Good
All the
night, sir.
best.
Thank you. Participants, the attendance link have been posted in the chat section. You please copy and fill that till whoever filled the form, you can leave the meeting. So thanks for today, and we will meet at the same time tomorrow. And once again, I thank you everyone. Jai Hind.